Alright, I believe most of us are here now. Let's continue from where we have left. Alright, now we are going to look at projections of solids that are inclined, wherein the axes are inclined to both, to VP and parallel to HP. So these conditions is similar in the sense that the process and everything, except that we have our front view now projected as our top view and vice versa. So we are going to have something very similar. All right, now we have hexagonal prism base at 30 mm and axis 70 mm has an edge of its base in the VP such that the axis is inclined at 30 degrees to the VP and parallel to the HP joint projection. In this type of questions, the question is very telling. It tells us mostly all about the conditions. So it's not easy. Alright, we have a hexagonal prism and it has its base in the VP. So that means that the base, the particular base itself is parallel to the VP itself. Right. And the axis is inclined at 30 degrees to the VP. So when we have an axis inclined at 30 degrees or at a certain degree, we are going to consider it as perpendicular to the VP in our first stage. Okay, always. We are going to assume it to be perpendicular in the first stage, and then we are going to incline it to the desired or to the actual angle in the second stage. So how do we proceed? We proceed by making our hexagonal prism profile, which is the hexagon we are going to draw it first. And as we are going to put, as we are going to incline at a certain angle, we are going to see if we are going to have the edge on the right hand side or a corner on the right hand side. So the question is telling us that it has an edge of its base in the VP. So as it is an edge, so it will be wise if we take a side on the right hand side and make it perpendicular to the horizontal plane or the XY line in this case. Alright, in this way. Alright. And we make that, we make sure it's like that, and we proceed on drawing
Excuse me, sir.
Yes.
Sir, your audio is not clear.
Alright. Just a minute. Alright. Has it been the same for everyone or is it only your friend? Is it clear for
Stuff for
No,
both?
sir.
everyone.
No, for everyone, sir.
It is clear now, sir.
Alright. Probably, yeah. Actually, I'm having this, the microphone that I'm using is of an earphone, so probably it might be stuck a little bit down in my collar. I hope it's better now.
Yes, sir.
Yes, sir.
All right, thank you. Yeah, better. We have a question, a problem that tells us that an edge of the base, that means one side of the base is and that particular edge to XY line. All right, XY line here means as per its position, it will be the HP or the VP. So as we are drafting in the VP, so our our edge here, which is this one, is going to be perpendicular to the horizontal plane. Okay, so the reason why do we do this is because we are going to tilt it, and this particular edge is going to still be in the VP, so it's going to lie intact. All right, so we make it like this in the first stage. All right, so we have our profile of the, when I say profile, don't picture the profile plane and everything. The profile means the shape of the hexagon as the front view. And from there, we have our top view. All right, and top view is touching the XY line because an edge is going to be touching this line in the next stage. So that is why we are letting it touch from the very beginning itself. So our axis is situated at the center over here in the front view. So our axis in the top view is also going to be over there. It's just that as it is directly beneath this point, we are not seeing the line. Okay, we are not seeing the dotted line or the dashed line. All right. So here in the next stage, in the next step, what do we have? We have the axis inclined at 30 degree to the VP. All right, and parallel to the HP. Parallel to the HP means that we are going to, as we are rotating it, see the axis is this one, right? It is still parallel to the HP. Just look at this. All right, so let me erase this again. All right. So in the next stage is as we have our axis along this, when we rotate it, we make sure that this axis is making 30 degrees to the XY line. All right. So we have that inclined at 30 degree, and when we project it, we get our actual front view. All right, and we get this by joining the corresponding lines which create a point. So A dash from here will be corresponding to A from this part to get the true A dash. All right, same goes for B and all the other points. And the visualization part, when it is tilted, we are going to visualize it like this. So when we look from the front, as this is a simple hexagonal prism, so this part is going to have at least one visible point. All right, okay. And so as this is the top, so the top part is also going to be there. All right, so this is the top part, and this line is going to correspond to both these lines. All right, and there is going to be a lower line, this part. So when it will be like trying to look from this direction. So as we are looking from this direction, we will have this part, this part, this part, this part all visible. Okay, so this part visible, this part visible, this part, this, this, and this. So this is the top part, so they are also visible, and the invisible part are joined together with dashed lines or dotted lines. It would be your choice. All right, if you had understood the previous ones wherein our axis is perpendicular to sorry, our axis is parallel to VP and inclined to HP, then you won't have much problem in this as well. Going to another problem, we have a pentagonal pyramid of base side 30 mm and axis 55 mm has a triangular face in the VP, and the base edge contained by the triangular face is perpendicular to the HP. Draw its projections. So now we have a pyramid. In the previous one, we had a prism, right? So now we are having a pyramid, and that pyramid has a base side 30 mm and axis 55 mm, and it has a triangular face in the VP. Right, and the base edge contained by the triangular face is perpendicular to the HP. Draw its projections. All right, I hope you guys are visualizing it. We have a pyramid and the base is pentagonal in shape, and the axis is 55 mm, and it has a triangular face in the VP. All right, so it has one whole triangular face in the VP, and the base edge contained by triangular face is perpendicular to the HP. Draw its projections. So it will be akin, it will be similar to one of the problems that we that we tried or that we explained in the later part of the class in the previous section, wherein one triangular face of a hexagonal pyramid is resting in the horizontal plane. Similar to that, we have a triangular face of a pentagonal pyramid resting in the VP, and the base edge contained by the triangular face is perpendicular to the HP. So that means that we will proceed by a pentagonal pyramid, wherein one of the base of the pentagonal pyramid is going to be perpendicular to the HP or perpendicular to XY line. Okay, and we are going to orient that, and we are also going to orient that on the right hand side in such a way that when we rotate it, that is going to touch the the vertical plane, because that edge is going to be a part of the face that is going to be in the VP. All right, so let's see this. Yes, that is that edge which is drawn vertical or 90-degree to the horizontal plane. So we have our side like this. All right, first our top view, and we flip it again. We flip this and make sure that this line OCD is sleeping over here. OCD is sleeping over here. All right, and then the rest we made it like this, and we project the points. We project the points and meet the projection from points from the top view and projections of points from the front view are being met to observe or to obtain the true front view, and as such we finally get our front view image. All right, so we must always read the problem carefully. The problem is telling us that a triangular face of the triangular face of the pentagonal pyramid is in the VB. I'll repeat that each of the pyramid will have a triangular face. It can be a square pyramid, it can be triangular pyramid, it can be hexagonal, pentagonal, heptagonal. All of those will have triangular face. And if that face is lying in one of the reference planes, one of the planes, then you make sure that you are rotating your edge, you are rotating your solid with that particular edge as the anchor point. Okay, edge would means if it is a pyramid and if you have a triangular face, then the edge I'm talking about will always be the base edge, and this must always be your starting point. All right, here this is our starting point. All right. Now we have a pentagonal prism of base side 30 mm and axis 60 mm has one of its rectangular faces in the horizontal plane. So it's the same as the previous one. It's just that as it is a prism now, it doesn't have a triangular face but a rectangular face now. So now that face is now in the one of its rectangular faces on the HP. It's resting on the HP and the axis inclined at 60-degree to the VP. And now the axis is inclined at 60-degree to the VP. Draw its projections. So on locations like on situations like this also, we are going to locate our prism in such a way that it is perpendicular to the VP, and we get this, and we make the axis inclined at 60-degree, and eventually we get the projections. This is one of the easier ones actually. All right, so whenever we do our annotations, we always go for the alphabets on the lower side and the numeric on the higher side. Here you will say, so that's quite the opposite. It's not the opposite, lower side in the sense that as this is closer to the VP, so we would often say the face which is closer to the reference plane should always be annotated with this alphabets, and the face farther away from the reference planes will be annotated with the numeric annotations. All right. All right. So more or less that's it from the explanation. I will try a hands-on a few of these what we have gone through today, projection of solids, and then we'll carry on to the projection of planes at having an inclination. All right, in our first example, we have an axis perpendicular to HP. Let me see some. A square pyramid of base side 40 mm and axis 60 mm is resting on its base on the HP. Draw its projections when a side of the base is parallel to the VP side of the base is inclined at 30 degree to the VP, all the sides of the base are equally inclined to the VP. All right. So I will not explain much of this anymore because I had already gone through this. I will just proceed on with how you would. Okay, how to proceed. So we have three conditions. So we are going to have three projections in one reference line. All right, we are going to have three projections in one reference line. So I will use that as this one. So it will be our XY line. All right. Our first condition, what does it say? Our first condition says that, okay, our condition says that our square pyramid is resting on its base on the HP. So that means that it is not floating above the HP. So I am going to have the pyramid base on the XY line itself in the front view. Now, when a side of the base is parallel to the VP, so I can start by making a line parallel to the VP. So let it be like this. It's 40 mm. All right. And it's a pyramid, it's not a prism. So it's going to have the apex or the tip. All right. So if I annotate the base as running A, B, C, D, so this would be O, 0. All right. So for the front view, as the axis is 60 mm, so I will have the axis line going all right. So for the front view, where S, A, and D are projected at one point, so it's going to be A dash, D dash, B dash, C dash, and O dash. Forty in dimension, 60 in dimension. First condition is clear. Second condition says that it is 30. One of the base, one side of the base is inclined at 30 degree to VP. So let me take 30 degree. All right. So this line makes 30 degree with the axis to the XY line. And if this is AB, CD, all right. So our point D is now going to come somewhere over here. Point A over here. Oh, sorry. Point C and point B. Height still here. So this is going to be our tip. So from point D to point O dash, it's still visible. It's going to be visible. Same goes for C to O dash. C dash to O dash is also going to be visible. And O to B also. Right. So the line O to A is going to be dotted line. All right. So this is your axis. So more or less it will be looking like that. Demarcation will go D dash. Sometimes it's better to pull your drawings a little bit downward. For me, I really wanted to fit it in one screen so that you can see it. You can pull it down so that you have more room for annotations. Okay, that's always helpful. If you have no restraints, if you have no, you know, restraints like the center or the axis is a certain dimension from the XY line, then you would have to abide by that. But if you do not have such, then you can simply pull it down, pull all of these things downward and make your drawing more better legible. So the next condition states that if all of the sides are equally inclined. As I have mentioned, equally inclined means 45 degree. So let's pull a 45 degree. All right. So when a square is lined at 45 degree, the property is that the diagonal. Sorry, it's going to be perfectly behind each other, so you are not going to be able to see the line hidden behind it. For example, for the case of point A, it will be right behind point C. Right. So you project the points. A and C will fall over here. All right. So here in my drawing, in my drafting, I did not, align my top views properly because I wanted this the point C to be slightly lower, because as my conditions A and B are very close to XY line. So to have a good view, to have a good drafting, visually pleasing, it is always better to have the tip part always at the same. Okay, like for example, this part, as well as this part for visualization would when an axis of a solid is perpendicular to the horizontal plane and parallel to the vertical plane. Now in the second condition, we have an axis perpendicular to VP. Am I still audible?
Yes, sir.
All right, okay. Just a minute. All right. So in this problem, we have a pentagonal prism of base side 30 mm and axis 60 mm, has one of its bases in the VP. Draw its projections when a rectangular face is parallel to an 15 mm above the HP. B. A face is perpendicular to the HP. A face is inclined at 45 degrees to the HP. All right. Now we have a pentagonal prism, and its base side has one of its bases is in the VP. So that means that one of the base is parallel to the VP, meaning the axis is perpendicular to the VP. Draw its projections when a rectangular face is parallel to and 15 mm above the HP. So in our first iteration, all right, I'm going to draft this in freehand. Okay, I won't be measuring everything, so that we are going at a faster pace. Now let's see this. We have a pentagonal prism and the base is parallel to the VP, and that means that the axis is perpendicular to the VP. So we are going to have that particular base, to um, that particular solid, that particular prism attached to the VP itself. So we are going to have that on the VP. In the first condition, a rectangular face is parallel to and 15 mm above the HP. So 15 mm above the HP, we are going to have one face. So as it is perpendicular to the VP, going to look like a line. All right. So we have one face parallel and 15 mm above the horizontal plane. Okay. So in order to have in order to have the front view, the top view, we are going to project these points. And as it is resting on the horizon, on the vertical plane, we are going to have it directly attached on the XY line. All right. So if we have been doing, and the closer ones are going to be A, B, C, D, and the other ones are going to be, the further ones are going to be 1, 2, 3, 4, 5, right? So let's say we start off by assigning this one as A, B, C, D, E. Okay. So correspondingly, we are going to have 1, 2, 3, 4, 5. And I'll tell you why. So we are going to have from here, as we are looking from the top, This line is going to be visible. This line is not visible. That line is visible. This is not visible. And this is visible. So subsequently, this point will be A, B, C, D, E, corresponding to the top view of that particular corners, of those particular corners. Here we'll have 3, here we'll have 2, here we'll have 4, 1, here we'll have 5. So our axis is 60, right? So as it is 60, so it will be just like that. So our first condition is met like this. Okay, so what is our second condition? Our second condition is that a face is perpendicular to the HP. So when a face is perpendicular to the HP, in our first condition, our face is parallel to the HP, right? Parallel to the HP. Now in our second condition, our face is going to be perpendicular to the HP. So perpendicular to the HP means we can start off by making one line perpendicular to the HP and proceed. All right. So when we have this, now that means that this is perpendicular. Okay. So let's have this as A dash, 1 dash, B dash, 2 dash, C dash, 3 dash, D dash, 4 dash, E dash, 5 dash. So it will be, so for here, we are going to have a top view of something like this. Corresponding to this line, we'll have this one visible. And corresponding to these lines, we are also going to have a visible line for D4, and it's also going to be subsequently be the line representing B2 as well, and as well as C3. All right. So here we will have A and E, B and D, and C. Here we'll have 1 and 5, 2 and 4, and 3 over here. Dimension, it's all the same. You can put it. Even here also, you can put this is 30. All right. So here our condition is met again. In the third condition, we have a face which is inclined at 45 degree to the HP. So we start with one line inclined at 45 degree to HP, and we start from that. Let me just employ this one for now. 45 degree like this. I hope this is 45. Yeah, this is 45. So we have something like this. All right, let's denote this as A1 dash, B dash, 2 dash, C dash, 3 dash, and so on. So when we project it for the top view, go down. Let's see how close these points are. And as we are looking from top, all of the lines, majority of the lines are going to be visible. So we have this line visible, this line visible, this visible. So it will be something like this. All right. So we'll have D over here, E over here, not D, sorry, A over here, E over here, D, B, D, and C. When the lines are too close, sometimes it's easy to be, to make mistakes like that. So always be careful. 1, 5, 2, 4, and 3. So these are our conditions. So, and this part, as this part makes 45-degree, be wise to say it so. All right. So this is when a solid is perpendicular to the vertical plane and parallel to the horizontal plane. All right. Now moving on to the next condition. This is the third condition where we will be employing the profile plane exists parallel to both HP and VP. So same goes for the pentagonal prism problem. Example should be example 3, which is problem 11.4. A pentagonal prism. All right. I hope everyone understood at least up till this point. Can someone confirm if I'm audible?
Yes, sir.
Yes, sir.
Yes, sir.
All right. So I'm going to assume that you have understood it so far. Yeah?
Yes,
Yes,
sir.
sir.
Yes, sir.
All right. Okay. Anyway, if you have been paying close attention, there is nothing too difficult to not understand. Okay. However, if you have been skipping the last class, it would have been a little bit problematic. Right. Just a minute. All right. A pentagonal prism of base side 30 mm and axis 60 mm is resting on one of its rectangular faces on the horizontal plane with its axis parallel to the VP. Draw its projections. Okay. So here we are having a condition wherein the axis of that prism is perpendicular to the is parallel to the VP, and when it is parallel to the VP, it is perpendicular to the profile plane. So that is why we need a profile plane for this particular drafting. Okay. And the profile plane is where the profile of this particular solid is going to be projected. So which will be the pentagon. All right. And remember, so far we always started with the profile of the solid, right? The pentagon side here. And here also we started off with the square base first. All right. So now we are also going to start from that. So that is why it would be nice if we can start from the left side first, and we are going to simply, oh, sorry. So, all right, let's divide it. All right. So now let's see. As we are going to have the profile plane, so we will have the principal axis XY line going in this direction, and X1 Y1 line that corresponds to the profile plane as well. So we have the base, not the base, sorry, the rectangular face of a pentagon resting on the horizontal plane. So when it is resting on the horizontal plane, it is going to be parallel to the horizontal plane, and also at the same time touching the horizontal plane, and we are going to see the profile on the profile plane, sorry. So this side we are going to have the profile plane, this side we are going to have the vertical plane, and this side we are going to have the horizontal plane. Or let's say this corresponds to the top view, corresponds to the front view, corresponds to the side or profile view. All right. Now, as it is sitting on the horizontal plane, so we are going to have, so partly this is also going to be the horizontal plane, but formation will happen here. So we are going to let it sit here. All right. So from here, or okay, let's anoint this first. So we'll have as this is the profile view, it will start with a dash dash 1 dash dash B dash dash 2 dash dash, and so on. All right. So it goes on this side like this. So the distance from the XY line is not fixed when it comes to the front view. So we'll simply take this line as it is. And the axis is 60. All right. So this corresponds to the front view, and axis line goes on like this as well. Okay, so in order to project the other points, how do? We let it go down. All right, so as I have mentioned, you can take this as a center and draw an arc like this. Okay, but for me, as it's a bit difficult, I will simply take a 45-degree line from each of the points, and that is going to make the same distance. Okay, instead of dotted line, you can use thin lines as well. All right, like 2H, 3H. All right, so here we are going to have D dash and 4 dash over here, and we are going to have, now you might be confused which one should be 4 and which one should be alphabet and which one should be numeric. So the thing is, the ones closer to XY line is always going to be the alphabetical annotations. Yeah, please don't be late. It's all for you. All right. D4, and here we have actually we have 2 points over here, so that means we are going to have E and C over here. Let's put it as C and E, and 3 and 5, and over here we are going to have A and B as well as 1 and 2 over here. All right, so these are the points that corresponds to it. Now we are going to, from here we are going to have what? From this line the lowest line corresponds to E5, right? So from point E, we have a line coming down all the way down, and we have point E. E will be here, and if it goes on, 5 will also be formed along that 5. So anyway, I already know that this is going to make a rectangle, so I can simply proceed on with a straight line. It's the base, it has to be visible, right? And the side must also be visible. So the top part is going to be formed from here. So this corresponds to C and 3. So this is going to be C and 3. So we have C and 3, and this will be a straight line yet again. This actually will be straight line. And here we have B and 2. And from here we'll have A and 1. Sorry, this is actually going to be the lower side, so it should not be, yes, in straight lines. I mean, sorry, in, yeah, straight line, it will be in dotted line. It will go on like this. the base. See, it's coming from this part and this part, so it's not going to be visible from the top part, right? And the topmost part is formed by D4. So we have this. All right, so what do we have now? D and 4 form the top, and the sides C and 3 and E and 5, and the base A and 1, B and 2. So this makes up our projection. And annotations part, the axis, if it is 60, we can provide 60 over here. Okay, and each sides, then we can show it over here. If it is 30, then it is 30. So when we have a profile, when we have a solid which is parallel to both the horizontal and vertical plane, we must employ the profile plane and get the side view, and then we will get the whole profile. We'll get the whole profile, as in we'll get the profile as well as the other projections like this. So we have our front view, our top view, our top view on our front view, our top view, and side view or profile view. Any question? All right. Now we'll move on to the next condition. Axis inclined to HP and parallel to VP. Let's switch to hexagonal geometry. Everything is pentagonal. All right, we have a hexagonal pyramid of base side 30 mm and axis 60 mm, has an edge of its base on the ground. Its axis is inclined at 30° to the ground. Ground here means profile plane, okay, and parallel to the VP. Draw its projections. All right. I hope you can visualize a bit what it's going to be. So we have a hexagonal pyramid of base, a pyramid. And yes, sometimes students get confused with pyramid and prism. Okay, don't be confused. Remember the pyramid of Giza, and it has a tip, right? The apex. So prism doesn't have tips or apex, so don't be confused. So we have a pyramid of base side 30 mm and axis 60 mm has an edge of its base on the ground. Now our condition is that when it is inclined at 30 degrees to the ground and the edge of its base on the ground. So an edge here, as I have mentioned, it's not a point, it's a line, right? So whenever we are going to align it, then we are going to make sure that it's this particular edge which we are going to use as the anchorage, as the point where we tilt. All right. So let's see a hexagonal pyramid. Okay. I think our page is. Yeah, we can use both the pages. So it is on the ground, or it's on the ground base. It's based on the ground. So that means that more or less our plane is going to be on the horizontal plane. Sorry, our solid is going to be rested on the horizontal plane. So it's going to be at an angle to the horizontal plane, and in the initial stage it's going to be perpendicular to the horizontal plane first. Okay, when it's perpendicular to the horizontal plane, we are going to see the profile as a top view. All right, so let's draw that profile as a top view first. Consider this as the XY line. It's a hexagon of 30. Let's say this is our hexagonal base, and for the hexagonal pyramid to form, it will look like we have diagonals going. All right, so this is the tip or the apex, and we can assume any name. Let's say it's the point AB. It's the line AB, which is going to be the one that's anchored to the ground. All right, so we are aligning this perpendicular to the XY line, so that when we tilt it, that will be the anchorage, and the axis will still be parallel to the vertical plane. So let's assume our first yes. So what's the axis? The axis is 60 mm. All right, so it will go on like this. So we will have one that looks like an isosceles triangle or two right angle triangle. All right. So here we'll have A dash, B dash, and here we'll also have C dash and F dash, and we'll have D and E dash. All right. So now the next step, what are we going to do? We are going to make this axis. We are going to make this axis 46, 30 degree to the ground. Okay, 30 degree to the horizontal plane. So first, let me just measure this height. It's going to be, okay, this is 60, but as per my scale, going to measure roughly around 1, 2, 3, 4, roughly around 4.4 units at 30 degree. All right. I'm going to position my this thing. I'm going to position my axis in such a way that before that I really need to know the dimension of this one, because that the edge is still going to touch it. Okay, the edge is going to touch it, so it will be roughly around from here 1.9 units. At this is supposed to be 60 because it's going to make, so as our triangle is going to be something like this, because this axis is going to make 30 degree, right? As this axis is going to make 30 degree, the line that we are drawing over here should be making 60 degree. Okay, so we start from this one. We start with the base. The base is 3.7 units on my scale at 60 degree. So half of it is going to be where my axis is. At 30 degree, I'm going to have an axis. Oh. All right, and I can simply join this now. All right, so we'll still have O and A, sorry. Okay, so from here I make sure that the angle this makes is 30 degree. All right, So from here, I'm going to project point-wise, point by point. I'm going to project point DE. So DE corresponds to this DE, right? So it will go all the way downwards. And from E and A, it's going D, B, it's going. So we'll have D and E over here, point actual D and E. So we can join this line actually. So DE is going to be here. And when we look from above, obviously D is going to be visible. And let's see CF. C and F are somewhere over there. So F can come here. F is here. C is here. Right? And as they are going to form the base, let's join this for now. All right. So A and B. A and B, even from the image itself, they are at the bottommost part. So they might not be visible. And as this C and F are the larger part, I mean the widest part, even if we look from above, then they are going to be below that. But let's see how it's going to be. We are going to flip it this side, flip this side, right? So let's put it like this for now. And what about point O? Yes, point O is here. It's coming all the way down. Point O is here. So from this point, we can see that O, uh, here it's, I'm saying E, right? Here is D. So OE and OD are definitely going to be visible. OE and OD. And as they are the widest part, F and C joined to O are also going to be visible. F. Okay. So when we tilted this side, it's the base part. See, when we tilted this side, the base part, it's going to be invisible, right? It's going to be hidden. So that is why we will be now joining all the other lines in dotted line. Dotted line, but darker than the other construction lines. So that makes up our true top view. This looks like 5, it's actually F, okay. So for the dimension, we can draw 30 over here and the axis as 60 over here. All right. So if the question says that a corner, like the one that we had done in the previous one also, if the question is say that the corner is in the horizontal plane and it is resting in the horizontal plane and the axis is inclined at the horizontal plane at so and so. If that is the situation, then we are going to put a corner on the right hand side. All right. So that means that more or less we'll have our hexagon oriented in this direction first. All right, and then we will have a certain our front view is going to look something like this, and we will rotate it, and we will rotate this, and then eventually we will get the true top view of this. All right, so always read the question carefully. And here the question here is telling us that the edge of its base, it's the edge, so it's this particular edge we are talking about, it's this edge. So this edge is this ABH. It is still intact, lying on the ground, and the axis is still parallel to the vertical plane. So this is our axis. So it's still parallel to the vertical plane. To the yes. So this, look at this. It's still parallel. All right. Any question? All right. If no question, then I will proceed on to a condition, our last condition, where an axis is perpendicular or is inclined to the vertical plane and parallel to the horizontal plane. All right. The other example that I have pondered a bit, pentagonal pyramid of base side 30 mm and axis 55 mm has a triangular face in the VP, and the base edge contained by that triangular face is perpendicular to the HP. Draw its projections. I hope you can still visualize it. A pentagonal pyramid of base side 30 mm and axis 55 mm has a triangular face in the VP, and the base edge contained by the triangular face is perpendicular to the HP. Draw its projections. All right. So from this condition, we can see that the pyramid is the pentagonal pyramid has a face in the VP, and one of the edge of the base is perpendicular to the HP. Okay. So now, in order to do this, we are going to orient our pyramid in such a way that it is in first go perpendicular to the vertical plane. The axis is perpendicular to the vertical plane, and we are going to flip it in such a way that one of the triangular faces is touching the vertical plane, is resting on the vertical plane. Okay, so in order to orient ourselves, so on our first stage, we are going to have, as one of the triangular faces has a base, as a line, as an edge. So we are going to make that edge on the right hand side, and we are going to make that edge, as per the question, perpendicular to the HP. Okay, even if it doesn't tell us that it is perpendicular to the HP, then if we are free to proceed, then making it perpendicular to the HP is going to be the easiest. All right, so we are going to have a pentagonal pyramid, one side. Let me save some space. All right, so this is our pentagonal base, and as it is a pyramid, so it is going to have one point at the center over here, and it's going to be something like this. All right, so let's, all right, so now we are going to flip this. So in order to flip this, we need a top view, right? We need a top view, and as it is going to be touching it, so we have to start from XY line itself. AB is going to be formed here, sorry, and our O line, now this is going to be, as per the question, 55 mm. Axis is going to be 55 mm for here. O, E and C base are going to fall there, and D is going to come here as well. So D, E and C. All right, so in the top view, this is we will have to see EC over here. Sorry, C0 is going to be formed along this, and EC will also be formed in that, but as it is directly behind C, then it is not going to be visible, so it will be a simple illustration like that. So far so good, I hope. All right, so what's the next step? The next step is that we don't have any specific angle. We don't have any specific angle. It's just that we are going to flip it and let this side sleep on the let that slide sleep on the uh, XP, on the VP, sorry. So that side is represented by this line, right? It's represented by this line. Okay, so now we are going to simply take the dimension of OAB and then let that be the base. Okay, and we are going to take all this angle, we are going to draw everything, we are going to measure all the angle of this. For me, I do not have, let's say, let me try to use this. So the length of AB is roughly around 1, 2, 3, 4.3.5 unit. Let's start from here. All right, so this will be A, B, and O. All right, so let's see the angle that it makes with this one. Roughly around 70, so I need to make it around 20 degree. The unit goes 3.2. I hope everyone follows me and know how to replicate this. I am simply I am simply replicate this into this, okay, and I am taking this particular line as this particular line, because this particular line is representing this face which is going to rest in VP vertical plane. So this is the line that is coordinating each part of the drawing. Okay, all right, now I still need to know the distance of all of these things. From AB, it's roughly around 1.9. So I have to measure that. And the axis is the center. It has to be the center, or is it not? 1.5 units. Actually, in this particular drawing, as the question does not tell us anything about the axis, so the axis doesn't play much role over here, but it's safe to show it anyway. All right, now we have this. All right, let's annotate this anyway. This is E. Oh, this is EC. This is D, and this is O. So now let's annotate A and B. A and B will be formed here, the base, and E and C. E is here, C is there. So when we look from front, then this part is going to be visible, right? So the whole base is going to be visible. Please. Sorry. C comes here. E comes here. D comes there. And O, same line as this. O is here. So that will be a straight line. From here, it will be a straight line as well. From below, we will have dotted line. Right, so this corresponds to A, B. This corresponds to C and E, sorry. And this corresponds to D and O. And that is our final projection. First stage, second stage, final projections. Any question?
Sir,
Yes.
in the first stage, could you please explain why we drew the pentagonal pyramid at an angle again?
All right. The pentagonal pyramid at an angle, in the sense you are saying that at this particular orientation, right?
Yes, sir.
All right. The reason is the question here. The question is already telling us that the edge contained, let me repeat the whole question, okay? The question states that a pentagonal pyramid of base side 30 mm and axis 55 mm has a triangular face in the VP, right. When we look at the property of a pentagonal pyramid, it has 5 triangular faces, right? This face, this face, this face, this face, and this face. So it has a triangular face, meaning means singular. One of the triangular faces is in the VP. It is directly in the VP, or it is, let's say, stick to the VP in one of the faces, with one of the faces. And the base edge contained by that triangular face is perpendicular to the HP. So this is our determining condition. Okay, the base edge contained by the triangular face is perpendicular to the HP. So of these five faces, triangular faces, we are selecting one face, right? So each face is made up of a triangular shape. So this, as per the question, the base edge contained by the triangular face. So in this illustration, our base edge is going to be this one, right? So far, so good?
Yes, sir.
All right. So as this base is making 90° to the HP, perpendicular means 90° to the HP, we are starting our arrangement by making this base, one of the base, edge perpendicular to the horizontal plane. And that is why, as we are starting with this particular base edge, as we are starting with this, the moment we make this 90° to the XY line or the horizontal plane for our case, the other orientation is related accordingly. Are you clear?
Yes, sir. Thank you, sir.
All right, that's good. Any other question? All right, I'll take that as a no. All right, from the exercises I have explained today, is there any particular ones that you want me to go and explain again? Or not particularly the example, also you can talk about, any topic like, for example, currently we are at an axis inclined to VP and parallel to HP. We can have an axis inclined to HP and parallel to VP also. In such conditions, do you have any question so far, or anything you want me to repeat? All right, I'll take that as a no, and I'm going to be glad that you guys have understood. That's good. All right. Now coming to the assignment part, so far what we have done in the class, especially the ones that I have taught, will be there. Right, so I will write here the different, I will share you this file anyway, projection of solids homework. Eleven point one. 11.4. Apart from this, I will be writing another example. Okay, I will simply say it as sample 1. I want you to try this. A hexagonal prism of, now this is a prism, not a pyramid, of base 30 mm and axis 70 mm rests on a rectangular face on the HP such that the axis is parallel to and 45 mm in front of the VP draw its projections. Can someone tell me what is the condition we have here? Like the position of your solid with respect to your reference planes. What do we have? Read the question carefully and just tell me what is the position of our solid with respect to the reference planes. Is it like it is parallel to HP and perpendicular to VP? It is parallel to VP and perpendicular to HP, or it is parallel to both the horizontal plane and the vertical plane? What is the condition? Someone take a guess. If you guess it wrong, also it is fine.
It is parallel to VP and HP.
All right. Yes, that's very correct. It is parallel to VP and HP. So when it is parallel to VP and HP, how do we do? What do we do? How do we proceed? When it is parallel to both the planes, what do we do? Anyone? What happens when it is parallel to both the planes? So when it is parallel to both the planes, on the top view and the front view, we cannot see the profile, right? So as we cannot see the profile, there is another plane which we must add. What is the name of that profile? What is the name of that plane? What is the third reference plane that we take in order to have the side view? What is that name? What is the name of that plane?
Profile plane.
Yes, it's profile plane. So that means that in this particular example, in this particular exercise, you will be drafting the side view, the front view, and the top view. All right. All right. So in our second condition, we are going to have a pentagonal prism, okay, and the base side of so and so, dimension so and so, stands on a corner of its base. Now, as it is a pentagonal prism, we are going to have 5 corners in one of the bases. Okay, so now it is standing in one corner. So that means that when we draft, we must put that particular corner on the right side, right? For example, something like this. So we have 5 corners. Okay, so we must make sure, as this is going to be the corner that is going to anchor that is going to fix your solid to the horizontal plane, we must make it on the right hand side. Not just the right hand side, we must align it with the existing conditions. Okay, suppose this is our pentagon. Now let's see what are the other conditions. The other condition is saying that the longer edge through that corner inclined at 45 degrees to the HP, and the face opposite to that slant edge, SLANT. Okay, this is slant edge. My handwriting is not okay. Slant edge is perpendicular to the VP. Draw its projections. Now the question is making our condition easier. All right. So now let's see. If this is let's say our suppose corner, if this is that corner, let me make it bigger. Wait. Suppose this is our corner. All right, the face opposite to this corner is going to be this one, right? This one, right? So this is the corner and this is the face opposite to it. When we have a pentagonal prism, we are going to have one corner. Let's say this is the corner, and that corner is going to be rested on the horizontal plane, and we are going to align it with the horizontal plane. And we are saying that there is a longer edge through that corner is inclined at 45 degrees. So if there is a longer edge, there is going to be the shorter edge, right? So which one is going to be the longer edge? It is going to be, as per our condition, our pentagonal prism is 30 mm base side, right? This is 30 mm, while our axis is 80 mm. As an axis is 80 mm, in a prism, the axis itself is the same as the height of this, the dimension of this. This is 80 mm. So definitely of this corner is carrying 3 lines. 1 line, 2 line, 3 lines. So of the 3 lines that it carries, this is the longer side. This is the longest side, right? So the longer edge through that corner is at 45 degree to the HP. So that means that this particular edge is going to be the one that is going to be inclined at 45 degree to the HP, and the face opposite to that, so probably this is the face. This face is going to be perpendicular to the vertical plane. So how are we going to align this one? We are going to align this. We are going to make it, as it is resting on the HP, we are going to first make it like this. The corner is on this side, and the corner opposite to that, the face opposite to that slant edge is perpendicular to the VP, right? So we are going to have a face, or from the top view, a side which is going to be perpendicular to the VP. So it will be perpendicular like this, and it goes like that. So somehow it will be like this, right? So this is going to be the corner where we are going to align our solid. So it will be here. Something like it, as this is the corner, so we will be at 45 degree. This will be oriented. Something like this, as simple as this one. And with this, we are going to have a point. We're going to project the points. So eventually we will have something like this. Sorry, with the base, as this is the corner. So it's going to stand in this particular corner. So we must make this into consideration. And this is the edge. That corner, the base still remains the same. Yeah, it was correct only. It was just that from this point, you will form something like this. You will find out something like this. Okay, the tip part. So this is the part which is going to be the lowest part, so we won't be able to see it from the top view. And this is the face that it talks of, this part. It makes 90 degree to the horizontal plane. So that means that this face, the entirety of it face, as it is 90 degree to the vertical plane, we are only seeing it as a line. So this whole plane on the top view, or this whole plane in the front view, this line, as it is perpendicular to the horizontal plane, vertical plane. All right. So you will find something like this. So in this example, what you have to consider is that it is telling us the positioning of our axis. It tells us that the axis is parallel to and 45 mm in front of the VP. Okay, so our axis is at a certain distance of 45 mm from the VP, so that must be taken care of. All right. So it would be wise if you have if you draw your top view first, and then from the axis you will have your from the axis you will have your XY line drawn, something like that. All right. I don't think I should proceed on with the projection of planes which are inclined to both the lines. So I will call it a day for now. And I believe that the next class also I will not ponder on projections anymore. We will go on directly to isometric drawings, isometric projections basically. And as I had mentioned before, So portfolio 1 submission is tomorrow, all right? And gear up for second portfolio submission as well. It won't be nowhere later than 2 weeks later. So probably it will be on the 26th or on the 27th, because on the 27th, as you are going to have a test on BCM, internal test on BCM. So make sure that you are not piling up your works at the very last. Okay. So for today's assignment, you have all of these. All of these are already in the textbook. Sorry, in the note file that I will share you, and we have done it today itself. This exercise itself will be similar to either of these, and these are the two which I want you to ponder a bit. And actually I have already shown you how it's going to look like anyway, so nothing too difficult, I hope. Any question? Any question?
No, sir.
All right, then I will take your screenshot. So we are 25, so 23 students. And just in case you are still using someone else's account, your Google account, with showing a name other than yours, it could be problematic, right? So you must change to your actual name, or at least a short form of your name, which we can know. Short form in the sense, for example, there are few names which may be too lengthy. Maybe you can put a short form, but at least have your second name or your first name as per your actual name, in such a way that we can look back and see your attendance later on. All right, can I know who is your CR now? I think I haven't known your CR yet.